Equilibrium questions. So the question is, I am taking one inclined plane of inclination theta whose angle is 30 degree. Now on top of this, I am supposing that one half of the cylinder, solid cylinder is kept, or hemispherical shell, you can take anything, hemispherical shell. As it is a hemispherical shell, that means half of the hollow sphere. If half of the hollow sphere is kept and this inclined plane is rough enough so that no slipping occurs, okay? So it is at equilibrium. Then what is the question? If I am drawing a line parallel to inclined plane, this makes an angle alpha with the spherical surface, okay, flat surface of the sphere makes an angle alpha with the inclined plane. Then the question is, what is the alpha value? Find alpha. So now object is at static condition. So I advise to the students, pause the video and try yourself and then see the solution, okay? So that makes you learning more effective. Then let us see. So as I told you, in rotational equilibrium or any equilibrium if you are solving, the basic idea is first identify the forces acting on the object. Now we know that here at this point friction will act along the surface, which will try to prevent the sphere from slipping, which will balance, if you want, mg sin 30, normal action will be mg cos 30. Okay, that is one thing. And second thing is, if I am drawing a normal, that normal should pass through the center of the sphere. Why? Because normal means that is this line is perpendicular to inclined plane as well as this line should be perpendicular to the sphere also. The perpendicular line to the sphere is, which is normal reaction, acting radially. If you are drawing a line radially, that will become perpendicular to this, or else you can think in mathematical terms. Inclined plane surface will become tangent to the sphere at that point. So obviously normal to the tangent is passing through the center of the sphere has to be, okay? So these are the two forces acting. Then one more force will act, that is, if I am drawing a perpendicular line to the sphere, this is the perpendicular line to the sphere, then somewhere center mass will be there. For hemisphere, center mass will be at a distance of r by 2 from the center. Center mass of the hemisphere is r by 2 from the center of the sphere. Then this is the center mass, then mg will act downward. So here you can understand one important fundamental, that is what? So normal reaction and friction both are passing through this point. Means if I am taking this is the axis of rotation, then normal reaction will create zero torque. Friction will also create a zero torque. Then only one more force is left on the sphere, that is mg, weight. Now the mg also has to pass through this point. Whenever all forces are passing through this point, then torque about this point will be zero. Because the question is related to equilibrium. So all forces should pass through one point. So that about that point object will be in equilibrium. Even similar case you can think in reverse way also. That is, normal reaction, friction, both are not passing through center mass, but mg will pass through center mass. That means, if I am taking the axis of rotation as center of mass, then resultant of normal reaction friction should pass through center of mass. So there are two ideas. The idea one is, as I am taking, see, this is the hemisphere I am taking, something like this. This is the hemisphere. Okay, this is the point of contact with the with the inclined plane. This point I am talking about. If I am naming it as A point, I am talking about A point. So this is the center of the sphere. Then normal reaction will be this, and this is the friction. Then if I am taking the A is the axis of rotation, then friction and normal reaction will create zero torque. Now this is the perpendicular line, and I am taking this is the center of mass. Now mg should pass through this point so that all forces are passing through this point will create zero torque. This is one idea. And the second idea is, see, as it is in rotational equilibrium, all torques should cancel out. That means, if I am taking the sphere again, half of the sphere, now I will talk about this is the center of mass of the sphere at a distance of r by 2, random number drawing. Then this is the some point where it is in contact. This is the normal reaction and this is the friction, suppose, and mg will act passing through this point. Okay, so already we discussed about this point. Now I am talking about center of mass. If I am taking the axis of rotation passing through center of mass, then mg will create zero torque. But normal reaction friction, they are not passing through center of mass. But about the center of mass, still the net torque has to be zero. That means the resultant of N and F is nothing but contact force. That contact force will be passing through center of mass. So whenever this happens, then the net torque about the center of mass will be zero. So this is some idea to solve the rotational equilibrium again. So you have to identify, you take some point as an axis of rotation, all forces should pass through it, then only equilibrium is achieved. Now let us solve this question. Okay, so as I want to find out alpha value, now I am rubbing this part. You can solve anyway now. I am taking this is the diagram. Okay, then see here I can write down mg sin theta will act downward. Now I am going with all mathematics. Then mg cos theta will be perpendicular to inclined plane. So I can write down friction should be equal to mg sin theta balance, linear equilibrium I am solving. Upward force is equal to downward force. And similarly, normal reaction is equal to mg cos theta. Then I can write down friction by normal reaction goes to tan theta. This is one thing. Now I want to go for torque acting. I can take anywhere. Now I am taking this is the axis of rotation. If I am taking this is the axis of rotation, then mg will create zero torque because about that point it is passing. But now normal reaction friction will create some torque about this point. Resultant won't create, but individual forces will create a torque. Then I have to find out normal reaction multiplied with the perpendicular distance. This perpendicular distance I require. Now we know that this length is r by 2. If I make a horizontal, not horizontal, along the incline I will do that. If I make it along the incline surface, something like this is line parallel to incline, then this angle will be alpha because we require alpha. So we know that these two are perpendicular. That means this is 90 minus alpha. And this angle, the angle inside the triangle. So you see one triangle like this. And this is the center of mass. And this is the normal line. And this is the center suppose. And this is r by 2. This angle will be alpha. And this is the normal line. Okay. So then perpendicular distance will become r by 2 sin alpha. So r by 2 sin alpha is the perpendicular distance for the normal reaction. Now we need to identify perpendicular distance for the center of mass. So then I have one point here. This is the center of mass and this is the friction. Now we know that friction is parallel to the line or parallel to the inclined plane surface. Means these two lines are parallel. Now I am drawing the one more line passing through center of mass and parallel to incline. These three lines are parallel to each other. Now what is the perpendicular distance? This will become the perpendicular distance. Okay, and the total length, this perpendicular distance will become r, because this is the one point on the surface and this is the center. The distance between these 2 points should be r only, radius. Okay, and we require this length. This length is nothing but, in this diagram, this is the length. Once check this, these two lengths are same, which is r by 2 cos alpha. So now this length is r by 2 cos alpha, total length is r, then perpendicular distance, this perpendicular distance for the friction about center of mass is r minus r by 2 cos alpha. Now I know the forces, I know the perpendicular distance, then I can go for equilibrium. But for equilibrium, normal reaction and friction should create equal and opposite torques. Obviously about the center mass, normal reaction will try to rotate in clockwise, friction will try to rotate in anti-clockwise. So I can write down normal reaction into perpendicular distance, r by 2 sin alpha is equal to, then friction, perpendicular distance, friction into perpendicular distance, r minus r by 2 cos alpha. Okay, then r by 2 will cancel out. Then I can write down this is f by n or sin alpha by 2 minus cos alpha is equal to, actually you can take r cancel out, multiply the 2, that's it. If you multiply the 2, then you will get 2 minus cos alpha, that is equal to friction by normal direction. We know already what is the friction by normal direction value is equal to tan theta, and we know that theta value is 30 given in the question, then it should be root 3, then 1 by root 3. Sin alpha by 2 minus cos alpha is equal to 1 by root 3. Then I can write down 2 minus cos alpha is equal to root 3 sin alpha. Then 2 is equal to root 3 sin alpha plus cos alpha. So then we need to solve that alpha value. So then I can write down root 3 by 2 sin alpha plus 1 by 2 cos alpha is equal to 1. Divide with the 2 this equation. So then this I can write down sin alpha cos 30 root 3 by 2 plus sin 30 cos alpha 1 by 2 I am writing as sin 30, root 3 by 2 I am writing as cos 30 is equal to 1. So then sin A cos B cos A sin B. Then sin of alpha plus 30 is equal to 1. Then alpha plus 30 is equal to 90. Then alpha value will be 60 degrees.